Hello, Honors Chemistry, and welcome to section 2.5, where we finally start talking about units, which are crucial things, right? Because obviously the number 2.5 has no meaning, right? Unless we add some units to it, right? So 2.5 pennies, not so useful, right? $2.50, not so bad, right? $2.5 million, that would be awesome, right? Or if we were talking about the length of a bug, right? If a bug were 2.5 millimeters, that is totally different than a bug that is like 2.5 inches, right? Versus, say, I don't know, some giant weird bug that would be like 2.5 feet or something, right? But it matters, right? Those units matter, which means that basically from here on out, every single numerical value that you write down will be accompanied by a unit. And if it's not accompanied by a unit, it is not correct, right? And you will not get credit for having a correct answer, okay? So tuck that away and make sure that you follow that rule. So here are just some common quantities with their standard SI units, right? Where SI is just the international standard that scientists use, right? So for length, we always use meters, right? For mass, it would be kilograms. For time, it would be seconds, and temperature would be Kelvin. We will talk more about Kelvin in chapter 3, like your book says, right? And then obviously we need to be able to convert between types of units, right? Because, for example, like for anybody who is big into baking, right? If you read a recipe written in the United States, right, it's going to use things like cups and tablespoons, right? If you read a recipe written from pretty much anywhere else in the world, right, it's going to be measured out in grams, right? And you're going to have to find a scale to measure those things out, right? So it is key that we are that we are able to convert, okay? Likewise, if we are measuring something in the United States, often we will grab a ruler, and that ruler will be marked off in inches. Whereas if we grabbed a ruler in pretty much anywhere else, it would be marked off in centimeters. Which means, again, we need to be able to relate the two so that way we can understand what the relative size of something is. Okay, so like it says in your guys' book, the ones that are marked off in red here are required to memorize, right? Which means that from here on out for the rest of the school year, any problem that I ask of you, these 4 conversions are what you would need to get you to the final answer, right? Obviously, some of these are convenient, right? Like if you memorized this one also, right? That would be convenient and it would save you a step or two. But you can use the 4 that are highlighted to get everything done, okay? And so what this means, right, is that this is a relationship, yes? As in 1 kilometer is equal to 0.6214 miles, right? And so I could say 1 kilometer is equal to 0.6214 miles, or 0.6214 miles is equal to 1 kilometer. It doesn't matter because they represent the same quantity of distance or length. Yes, does that make sense, right? Likewise, 1 inch is equal to 2.54 centimeters, or I could say 2.54 centimeters equals 1 inch. Doesn't matter. They represent the same quantity, right? Other life ones we should know, right, that aren't listed here, right? I assume we all know at this point, right, that 16 ounces equals 1 pound, right? A 16-ounce steak is a 1 pound steak, right? Or the fact that 1 quart is equal to 4 cups, right? So like when you go to the store and you buy a quart of heavy cream, right? That quart of heavy cream has 4 cups in it, right? So if you're going to make whipping cream out of it, you would need to know that conversion, right? Okay, those are other ones you should just know, life things you should know. All right, table 2.2, this is the version that's in your guys' book, which tells you just the relative size of each of these units, right? I prefer this one for doing math, right? This is one that's posted on PowerSchool because this one helps me to more easily come up with the relationships, okay? So I'm going to explain to you how I would use this table, right? If you prefer the exact method written in the book, you're welcome to use that also, right? And if you are finding yourself very fuzzy, even after we finish the skill builders here, make sure you come see me sooner than later, okay? Most of these things really don't take long to fix, as long as you are good about getting on it soon. Okay, so if we take a look at this table, right, we will see that it's organized by base unit right here. And base unit is any SI unit that doesn't have a prefix on it, right? So this could be like meter, it could be like seconds, it could be grams, it could be, I don't know, liters, for example. It could be any of those, right? And these are all the different prefixes that we could attach to it, okay? So, and base unit has an exponent of 0. So let's talk about how we would use this, okay? So we are always going to set up a relationship, right? Just like we saw on the previous page, right? And it doesn't matter which one goes on the right or the left, but it's always going to be one big thing, right, is equal to lots of smaller things, yes? And we think about the land of scientific notation that we talked about, right? When we say lots of something, right, it should be 10 with a what kind of exponent? Right, a positive exponent, right? Because there are lots of them, right? So one big thing is equal to lots of smaller things. Yes, that's just how that works, right? So let's practice that, right? So let's say we're talking about meters here. So 1 meter is equal to, let's say we want to come up with some millimeters, right? Millimeters are smaller, so 1 goes with the bigger unit. Since millimeters are smaller, but it's 10 to the third, we would say 10 to the third millimeters. Yes, there are 1,000 millimeters equal to 1 meter, right? Now, if I wanted to do the relationship between meters and kilometers, now the bigger unit is kilometer is equal to 10 to the third meters. Yes? Does that make sense? Right? Let's do another one, right? Let's say that we wanted to talk about gigaliters and liters, right? Same thing. Which of these is bigger, right? 1 gigaliter is equal to 10 to the ninth liters. If we wanted to write a relationship between nanometers and meters, which of these is bigger? Right, meters is bigger, so 1 meter is equal to 10 to the ninth nanometers. Yes? Now, let's say we wanted to go across that base unit, okay? There are lots of ways to do it. This is the way that I think is most logical to me. So this is what I would do. So let's say I wanted to go from kilometers to millimeters, right? I would see that kilo is 10 to the 3 bigger. Milli is 10 to the 3 smaller, right? So that means I have to go 3 places to get to the base unit, 3 more places to get to milli, which means a total of, right, 10 to the 6th is the relationship there, yes? So same thing, which one's bigger? Right, kilometers bigger, 10 to the 6 millimeters, right? Or let's say we wanted to come up with a relationship between teragrams and attograms, right? So which of these is bigger, right? Teras, right? And to count our teragrams, from tera to the base unit is 12. From the base unit to attos is 18, right? So 18 plus 12 is, right, 10 to the 30th attograms, yes? Always lots of little things to one big thing. Yes, does that make sense? All right. Thank you for listening. In the next section, we will do a boatload of skill builders to sort of emphasize the art of doing a conversion and reading this table. All right. Thank you for listening. Be good, and I'll see you soon. Bye.